So I just thought I'd start first with a bit of background before I jump into the entire presentation, because Tosca BI is sort of an evolution of Tosca functionality itself. We actually got almost by accident involved in a couple of BI products at two large banking customers originally in Australia. And we saw what they were doing, and I got an allergic reaction to doing anything more than once if I couldn't automate it. So I had a look at what they did over a couple of weeks, over a weekend initially for the initial prototype, and then over a couple of weeks, I wrote them a prototype on how they can actually do what you'll see as the first bit of functionality in Tosca BI. And we tried it out, and it worked, and it saved them a lot of time and effort, but then we found some other things we could do. We found a whole bunch of other tests that could actually be applied. So this started being sort of a pet project with these two particular customers. We had a very close relationship with them, a lot of Tosca being done, a lot of SAP, a lot of Oracle Forms was actually installed there as well. It was a pretty big place. And after a while, I actually wrote a quick video to show one of our partners in India. They were actually, this bank was actually using TCS as their strategic outsourcer, and these guys wanted to use it offshore as well. So I wrote a quick video just to describe what the product did and how it worked, and our marketing people somehow got their hands on it, and they published it on the Tosca public website. And then a German consultancy company came to us and said, hey, we really like this, can we please borrow it? So out of nowhere, we suddenly got interest in saying, hey, you've got this product. It wasn't a product, it was a prototype, but anyway. We've got this product, how much does it cost, and could we please install it at the two largest banks in Europe? So at that point, Wolfgang dragged me from my comfy home in Sydney back to Vienna and said, Alex, all right, now we need to put a team around you and build this product. So this was sort of 3 years ago, 2 years ago, we released the product. In the back, giving the demo halfway through is going to be Alain Traechslin. He's the product owner. Strategically called the chief monkey herder. Just worked out that way. So what I want to show you is just some of the fun bugs that we've sort of seen in BI and data warehousing specifically. So I want to start with just a simple presentation of what your typical ETL load looks like. We've got a source system with a whole bunch of tables, and we've got a target system where we're dumping it to. So typically, we've got all the constraints is handled for us on the source system. So the constraints, like all our uniqueness constraints, our foreign key constraints, all that sort of fun stuff is handled in the source, and we assume that's correct. When you move it to your data warehouse on the right-hand side, that's typically dropped, right? So you don't have those constraints. You just copy the data across and hope it goes right. So what are some of the problems that we see? Well, this is where it actually gets funny, because one of the first problems that we saw was you ended up with additional tables in the source that never were copied. They just didn't appear on the target system. So, what were they tables? Are they important? Are they not important? Nobody knew. Or more interestingly, we had tables that had their data copied once, which was great, I guess, until people realize that we're now we're doing our regulatory reporting on data that's now 6 months old because we haven't continued the ETL process. So these sort of issues started cropping up more and more, and we needed a solution for it. The next problem was when you have a lot of sort of satellite tables or auxiliary tables to a system which don't have a lot of data. In testing, you might actually write the script that actually extracts the data correctly the first time, and then you get that second load of data. And because the developers put in a greater than instead of a greater than or equal sign to your load, you might miss some data, right? You miss a couple of rows that you won't notice. Or alternatively, you actually double up on a row, right? Now, in a normal relational database, that'll get caught out as you're breaking your uniqueness constraints or something like that, all right? But on your data warehouse, you don't do it. You just double up your data. Now, if it's 1 or 2 rows, how quickly are you going to notice? How many times have you reported on that data that's now incorrect? Right? How are you going to find it? How are you going to roll it back? So these sort of problems became quite interesting to sort of solve. We talk about being able to shift left, being able to catch these as early as possible, because once this data is copied from the source system, once it's in the data warehouse, once it's transformed, now sits in a dimension table, now sits in your fact table, how do you roll back 3, 6, 9 months worth of data errors like this? So what we came up with is, all right, we need to be able to first verify this type of data is correct beforehand, before we actually get too far, and then able to trace that data across and how it goes. The other problem I'll show you that was a fun one was you start having data where you just haven't copied a column, right? Whether the column was added later after the ETL process was written, or it just wasn't included. So what you end up with is you might have the metadata structure on your target system, but all the values inside that column are nulls, or whatever the default values are. Right? So for example, numeric instead of null, you might have a 0. So suddenly you're now reporting of values of 0 constantly. So what's the ideal solution? Well, the ideal solution here would be we need to run metadata checks to determine whether, for example, our source and target are actually the same, whether they're compatible. We need to write completeness checks, right? We need to write a test that sits there and makes sure that we've got either algorithmically or by row counts, for example, to make sure we've got the actual same data, source and target. Whether we've got a historic table, we need to make sure that we just select the right tables, but the data has been copied correctly, completely. Referential integrity. If I'm copying, and using the insurance company as an example, if I'm copying a whole bunch of claims, I want to make sure I copy the associate policy records with it as well, so that the data is complete. Uniqueness constraints. We talked about how to catch those duplication problems when you copy data twice. To give you a real-life problem, we actually had a fantastic, one of my fantastic early customers, they were actually copying the data using a CDC method. So basically every time the data changed, they just copied data across to their warehouse. Except they were copying the same data every day for about 3 months before anyone noticed. The new data was triggered the change, but there's the old data that was being copied all the time. So the change never actually got to the data warehouse. So fun things like this. And nullness, obviously, for catching default values or things that aren't being copied correctly. So then we hit this sort of the nail on the head, so to speak, when we say, well, I'm not going to do this for, what, 3,000, 5,000, 6,000 tables? How many tables do you have in your data warehouse that you're copying across? That's a lot of testing to do. Well, these sort of tests is what we call vital checks, right? There's not really tests of any value. They're actually tests to see if it's worth testing, because your real logic, the real problem is going to be in your transformation. So these tests is what we first created in that prototype to be created automatically, right? You give it your source system, you point it at the target system, these tests will get created automatically. And Alain's going to show you how that's being done. If we could hear him, otherwise I'm going to have to talk over him.
Okay, perfect. Thank you, Alex. So I'll show you in our demo system. And I have to sit back here because we couldn't put the laptop on stage. But it's a live demo, that's proof. So what we're doing is we launch our vital checks. And how we do it is we say, in this case, we have tables in our source system, which is MS SQL, and then they are being copied onto our target system, which is Oracle. And so I'll launch this wizard, and I'll choose first the source system, claims warehouse, and I'll choose all of the tables. In this case, it's only 21, but the same concept applies if it's 21,000. I've chosen my source. I'll go next, and here is my target. And I said it's the claims warehouse on Oracle. So I'll connect, get the tables there, say next. And what has been done here is all tables have been matched. So all tables from the source have been matched with the target. There's one table that has not been matched because it's an additional table that is on the source system but not on the target. For all the test types that Alex described, your metadata tests, your completeness test, uniqueness, referential integrity, and nullness are selected by default. I'll just click next and say, create me those tests. What I now end up with is 72 tests in total. So these are individual tests. And we have 20 tests in metadata, 20 completeness. There are fewer uniqueness tests because not all tables have uniqueness constraints. And the same applies for referential integrity and nullness. Now, but before I run it, I might just show you quickly what has been generated. So I'll take a uniqueness test, and I'll jump to the test case. And all we see is an SQL that is being generated for us. Like all those 72 tests have some sort of SQL that has been auto-generated from the wizard because the data has been read from the database, and because the data is on the database, we could auto-generate those SQLs. Let me run them for you. So we see here at the bottom, got the progress bar. And because it's just small SQL that are executed, we can run them nicely in parallel, and they don't put too much load on the server. So this should finish in 40 seconds, roughly. And we've now executed 72 tests. But what does it mean, 72 tests? As Alex said, we have now checked that the metadata has not changed since last time. Well, in this case, it's just now that we've created it. We've checked that this row count, so completeness in the source for all tables, for all 20 tables, is the same on the target. We've also run uniqueness tests. So if data would have been copied twice, we would have picked them up. We've run referential integrity test. If incomplete data sets would have been copied over, we would have picked them up. And nullness, if we have additional columns that have been added, we would have picked that up as well. So pretty good test to start with. Please, Alex.
So that's, am I back on? Cool. Next. All right, so you like it so far? Not too bad? Cool. So the next part is, what are my favorite sort of bugs that you see sort of constantly. Every customer that I've been to, typically we sort of start with these bugs and then work out why they actually occur. And what we typically see is this sort of stuff, right? This is a nice simple sort of, nice simple test that we have here. We're just looking for tables that have, claims that have no policies assigned with it. And we're just joining a couple of tables and we're picking stuff up and just making sure that we actually don't have any of these records. So it's a negative test to make sure our data now is correct. And I've got 20 of these, 30 of these failing overnight. And as the poor tester, I didn't write this SQL, somebody else wrote this SQL, and I've got to start debugging this SQL. Now that's a simple example. If you look at, as I'm sure you can imagine, some of the more complex transformations would be, wouldn't fit on this slide. So then you have to debug it. And it's hard enough to debug this sort of stuff if you wrote it, let alone if you wrote it 6 months ago. If you have to debug someone else's SQL code and you don't know what's wrong with it, you don't know what the root cause of the problem, why it failed, that becomes then significantly harder. One of the most common problems that I've seen in pretty much every organization I've been to that's the cause of this is not actually a bug, a software bug or a problem. It's actually a lack of communication. And it's a lack of communication between the testing team and everybody else. Since your data warehouse is a living structure, there's always things changing in the data warehouse or things changing in the actual source systems. It usually involved multiple teams. It might not even be your team's data that's actually being changed, but what the root cause of this typically happens is, well, someone's added a table, someone's renamed a column, someone's renamed a whole table, things have simply moved and the test team hasn't been informed. Right? So the biggest problem here is you're suddenly out of the loop and you don't know what's changing. So none of your tests, none of these complex tests that are doing large joins, long computational processes, taking a long time to respond, are even worth running if your foundations is wrong. So you remember when I first showed you the tosca wizard, the tosca concepts of uniqueness, completeness, metadata, we're actually defining that these tests are not necessarily tests themselves, but they're tests to see if it's worth testing, right? Those sort of tests would have told us, for example, if I'm running a giant join to compare this table against this table to make sure I've got the right data, there's no point doing that if the data has been copied twice already and I can tell that with a shorter test. There's no point doing it if the table doesn't exist. And one of the fun things that we're trying to do in the DevOps world is we're trying to get answers back quicker. we don't want to be waiting for our SQL to finish half an hour later to tell us that the test is not going to work. I want to be able to know now whether that test is even worth running in the first place. So one of the fun things you can do with Tosca is you start scaling your tests from what sort of test will actually tell me whether it's worth running the other tests, right? So we start structuring our tests in such a way that we have tests that reinforce each other, right? The metadata test simply checks the metadata of the system. Are the tables the same as the ones I wrote my original scripts for? And those things take seconds. You're just querying the system tables. You're not querying anything very complex. And if those things can tell me in a second across 100 tables, across 1,000 tables, that it's not worth running my large transformation tests, I've just saved all that time not waiting for it. Next level, I can test my completeness. Does it have data? Have we actually loaded that environment? There's no point doing a two-handed join if one side of it doesn't actually have any data. Why wait? Same with uniqueness. There is no point trying to get a join across if you've got a double up of rows, where uniqueness tests would have told you that ahead of time. So with these tests, we actually have a way of being able to verify that the environment is correct. And rather than trying to sort of work out what actually is the root problem of my script on the way and the right, we start shifting to the left, finding the problem earlier and earlier. So the ideal solution, right, is, as a concept, what should it do? First of all, if I'm going to be running my test, it should tell me which tables, which columns have been changed, added, deleted, right? It should then tell me which of my tests have actually been affected by this. It should automatically update all those tests, especially those tests that I created earlier. And for those tests that it can't automatically update, it should show me traceability to know which one of my tests I need to physically eyeball to understand whether those changes are actually going to make it fail in the future. Okay? And that's what we have. Alan, over to you.
Yes. Okay, so what we're doing is we are simulating such a change. And to do so, I'll jump to my SQL source database, claims warehouse, and I'll just change one of the columns. And I'll change this one, and I'll just rename. And what this does is we're simulating that, okay, the tester has not been informed. We've now changed the column name to crazy new one. And the tester now needs to find out or update his tests so it takes the new changes into consideration. And so how this is done is we go to the test case design section, and we select the test types we would like to update. We then choose our update wizard again, and the data is now reloaded, and we go to the matching, and I would have expected to have an error here now. I think I've not saved it. So I canceled this, sorry. Correct. I think I should have saved here. Okay. So let's do this again. I'll open my update wizard. And I've now have a status that tells me, okay, here I don't have a complete match. And what we see is that our source column could not be matched to a target column. I can match this individually, or I can leave it for now because I want to show you what's the impact. So I'll say, okay, that's fine. And I'll press finish. And what we now being informed is, okay, we have had runs for this match. Do you want to update our tests? And if I say yes, please update. So what we've done is we've changed one column on a dimension table. and the dimension table is affecting uniqueness and referential integrity. So I said, yes, please update me, and what has been done, my test cases have been updated to take that change into consideration, as well as my execution list. If I want to know what kind of changes have happened, I'll go onto my test sheet, and I'll just choose the filter. And we have a status here. And what we see is the status for metadata has changed. Why has it changed? Because metadata has been adapted. So we see now we have the crazy new name column in here. The same goes for completeness, but for completeness, there is no effect to the column, so we don't have any changes here. However, uniqueness, we have one instance that has been deleted. So this is the old one, the old column, that has been deleted, it's not there anymore. If I would have mapped the field, this would be a new instance that has been added. And so me as a tester, I can see, okay, it had an impact also on the referential integrity. 2 instances have been deleted. That must be from the tables that are referencing that primary key that I've changed. So that's a really good way of updating your entire set. So Tosca is maintaining it for you, so it makes it really easy.
Cool. Thanks, Alain. So, 2 more bugs that I want to share with you. This next one is anyone who's done any sort of development in a large organization has seen this one constantly when you're trying to merge libraries. But in the BI space, it's a little different. So if we look at our typical, we started with this diagram as our typical BI structure, right? We have some tables, we have some other tables that go somewhere else. But that's not really what is out there, right? What typically happens is you're developing something, you're testing something, and then it goes to another environment, right? You've got lots of environments in your BI space. Let's see, there we go. You've got lots of environments in the BI space. You've got lots of different tables in the BI space. If you're trying to integrate what you've just tested in one environment, well, you better make sure that the structures, the data, the reference tables, the lookup tables actually are the same in the next environment, and the next environment all the way through to production. Because when you clone an environment and you don't copy the right data, you don't copy the right changes, you haven't applied the latest fixes, what do you get? You get an integration nightmare when you're trying to get your code out of test and into integration, or worst case scenario, you actually launch it into production and all of a sudden it doesn't work. It doesn't behave like it did in the previous environment. So this one is actually, I can give you a real life example of this one that actually for one of our telco customers, they had a table that it was actually their lookup table for the various levels of plans. That if you're on this plan, then you make a phone call to someone within this location with this area code. This is the rates you get charged, and they actually changed that plan. And the updated values were actually in their test environment, but they hadn't updated that lookup table in their production environment. And they didn't notice for 2 weeks. So lots of people suddenly were on the front page of Australian newspapers going, Vodafone charged me several $1,000s for my telephone bill and shouldn't. Anyway, fun stuff like this happens. Now, you can test for this, right? This is actually pretty simple. This is what automation is all about. Automation is about repeatability. Automation is about, if I've got one thing here, I should be able to point it to here and run it again, right? I should be able to test that what I've got in environment A is the same as in environment B. If I've got my test environment, it should be a reproduction of my production environment, not in the actual data, because obviously we're using anonymization, we're obviously masking the data, but in the structures, in the rules that make up the data. If you look at one of those earlier scripts, the number of policies that number of claims that have no policies attached. Right? Number of the actual metadata that underline, the number of constraints that you have applied to the system, number of transformations, all these things should be applied. So with Tosca, once you've actually created this fundamental vital check structure, it's very easy to apply to different environments, which Alain will now show you.
So let's continue on this example that we've got. We have here our execution list section. And so far, I've just run it against the environment that I pointed it to in the beginning through the wizard. There is one thing I didn't show you. There is a configuration parameter that is called dev. And what that indicates to me is that this is executed against the dev environment. Now, if I want to run the exact same tests, as Alex explained, the best thing to do is to create a copy of this execution list. And so this one I'll define vital checks against dev environment. And now this copy is, I would like to run this against my integration environment. And I have copied the execution list, but I have not copied the actual test cases. The execution list is just a collection of test cases. And here we have the exact same test cases that are executed in the integration environment as in the dev environment. The only thing I need to do here is I'll need to change my configuration parameter. And so I'll change that and say this is my integration environment. And so now I have two execution lists, but from a maintenance perspective, I'm still just maintaining that one test set that I've got here. But I run it now against two different environments. So very easy way to switch between environments and to address the problem that Alex described.
If you could, Alain, can you just jump back to Tosca for a sec? The one thing I want to point out is, since we're in a Tosca-friendly auditorium, I guess, a Tosca-friendly meeting, as you guys probably can tell if you look at the test case, look really carefully at the test cases, every single thing that's actually created there is based on a template, right? So the definition, for example, for completeness, you might have historization in your table. So you need to include what are the historization columns that actually exclude the rows that are not active, right? So you would actually modify that template. So in the same way, when you've got multiple changes between your test, integration, dev, whatever environments, whether it's column name differences, whether it's DB database differences, you can actually implement all those differences in the template. You can implement them inside your configuration parameters. You've got options. Everything here is configurable, right? Tosca provides you the raw data. This is what the test sheets are for, but it's up to you to then customize the templates to suit your needs. Okay, so don't feel like we're creating SQL that you can't edit and it comes out of nowhere. The SQL is in the template, and you guys can select your own templates. If you create your own templates, Tosca's wizard will use those instead. Cool. All right. The last bug is actually my favorite bug of all time ever. So it's a good one, I think. So this was actually at a really cool insurance company that I really liked working with. And we were doing a pilot only for doing profile tests with Tosca. So slightly more complex. We did the vital checks. That was easy. That was rolled out. So now we're doing profile tests. We're actually looking at data. And one of the things that we were pushing and we actually got involved with at the end was we actually got Tosca testing their production environment, right? Tosca's being used in test, Tosca's being used in their integration environment, and Tosca's actually being used by the system admins as a monitoring tool, as an additional monitoring tool, right? So I'll talk about that more in a second. What we actually had was, this like a lot of companies, this company has actually grown by acquisition. So there were lots of different insurance products under lots of different brands. We were testing one. There was this other one that was actually running in parallel to ours. And the way the system worked was there was a nightly batch process that took all the claims that actually had been approved for payment to be paid out to either the contractors that were fixing the people's roofs or directly to the people making the claim. And a process would run overnight, and that process would actually take the money and actually deposit it into the appropriate accounts, whatever the nominated accounts were, or print the check or whatever was appropriate. And something really cool happened. I love my little animation. I added that. What we actually then had was we had a race condition on a process running on one of the P systems that was actually running this payment transfer. So the IT admins saw that, okay, this process is in a race condition, it's not responding anymore, right, we're on top of it. They killed the process, restarted the service, everything looked green, everything looked good, right? And the system kept running, no errors, no nothing. A week and a half later, they're noticing a lot of people calling asking, where's my money? So what actually happened was this payment processor was actually jumping out and dying without throwing any error messages. It was just dropping straight out. Something had got corrupted. So instead of actually trying to do something, it just returned back to the prompt. So as far as everyone was concerned, it worked, right? Except the people waiting for their claim to be paid after they've been paid, yes, you've been approved. Now, at the exact same time, we were actually running exactly the same type of scripts, right? We were actually creating profiles that said, all right, show me all the claims that are in whatever state they are. So, for example, ready to pay, or it's a new claim, it's a claim that's waiting to be audited, it's a paid state, right? Show me the number of claims we've got per state, per location in the last 24 hours. And we were monitoring that value isn't going to fluctuate by more than 2% on a daily basis. Right, so we knew that if there was an unusual system event, for example, a flood, okay, then we'll notice a system difference. But on a normal day, those things should be pretty standard, right? You shouldn't have giant deviations in your data. So we would have noticed, for example, that an entire day's worth of processing on their system hadn't happened. But they didn't have our tosca at that stage, they just had us. Now, one of the really cool things about the fact that we were running this at the same time, we actually showed them that our profile test would have actually caught that. What's more is the system admins, their system admins that are actually running it, we actually convinced them that, listen, you're already running tests, right? You're already running tests, you just don't call them tests. They were really confused. They looked at me and says, what do you mean? Listen, are you not testing system memory? Are you not testing disk space? Are you not testing system latency? Those are tests. Right? You're calling it monitoring tools. You're calling it Tivoli, you're calling it Nagios, you're calling it Splunk, whatever, but they're tests. I can provide you the Tosca execution as a service. You call this a web service, or you call this batch script, it'll return you an answer. You can tell us when something goes wrong, right? We're providing a Tosca service to the system admins. What that means is they don't have to know what the testing tool does. Right? All they have to know is, did the test pass or not? And it adds, for them, value of the actual test because it tells them more about their system, their production system, the thing that they're actually responsible for. Right? So that's what we integrated. That's what we actually brought in. And it would have caught that while the system that didn't have Tosca didn't test it. So what Alain's going to show you next is he's going to show you how we can actually create a profile test in Tosca and how we can execute it.
OK, thank you, Alex. So these sorts of profile tests, we do them in test case design. And I'll show you one. And it looks like this. And that might look to you a bit complicated. So let me take you through it. So what we have here is horizontally, we've got the different instances. The instances is equivalent to a test case. And in here, we're testing brands. So we have different brands.
Alain?
Yeah?
Just before you go into it, the reason this might look complex is this is not a demo. Okay? This is from one of our actual customers who's given us, we've taken away company names, we've taken away product names.
Say which one.
Sorry?
Don't say which one.
Don't say which one. Okay. But this is actual complexity for an actual insurance company. So the things you're seeing here is not actually a demo. This is real data.
OK. And so what we have is different brands. And we want to test those brands. And we want to test how many claims against this brand have been claimed or are there. And so we have a verification point at the end, which is our claim count. We got the variance that we expect. And then we have further up how we identify the brand and the the measures. And the brands here are just numbers. And the measures are a bit more realistic or tangible because there are actually SQL statements behind it. However, this is just an SQL statement that had to be created here once. And this is being reused across the different brands. But there is a filter to it. And on this filter, we distinguish between the brands. Now, the nice thing about this one is I'm kind of hiding this complexity. Because if I look at this view, I can now see nicely, OK, I've got in total 14 brands that are tested. So I've got my different filters. These are my where clauses. And I've got information on what kind of, how these claims are identified in an SQL. And what I'll do with this is I link it up to that template that Alex explained earlier. So I've got a template here. And this is the main template that I'm maintaining. And we have information for the database, the table, the filter that we've seen. And all this comes from that test case design sheet that we've seen before. And the template instances are automatically generated based on this template, because the template is linked with the test case design sheet. If I click here, I see we have 14 instances, the same as in here. And all of them have the relevant data to identify those claims. And it's now, for me as a tester, very easy to add additional brands that I would like to test. And so, for example, what I can do is I can say, create me a new instance. And this is now my brand 15, for example. And I can use now my test case design to select the relevant data. So the brand 15 is identified through this filter. I can also select what kind of claim I would like to measure. So for example, it could be the rejected count. And then I'll say how many. Now, in this case, I expect 10,000 with a 10% variance. Now, what this is it's a really nice abstraction to concentrate just on the what do I need to test, and I'm not dealing with the complicated SQLs that are required. And because I've now added this instance, I could go back to my test case section, and I can say, please reinstantiate this. And I've now successfully added a 15th profiling test that has the data that I've just supplied.
Cool. All right, thanks, Alain. So in summary, make sure your foundation's stable, right? That's the first thing. Second of all, don't do it manually. For the love of God, I think that's the one thing that we've actually taken away from this conference that we've said constantly. The foundation checks that we talked, those vital checks, have them created automatically, have them maintained automatically. They should be completely simple and out of the way, because where your majority of your work is going to be spent on those transformation tests that you need to run. Similar to what Alain just showed you, that's where your intelligence is, knowing what the actual business is supposed to do and how it's actually supposed to transform the data. All right? Once you've got that, automate it, make it simple, make it readable. One thing that I really liked from the Vantive presentation, if you guys saw that, or WorldPay I should say, was when Sandra was talking about how you can actually, you should rethink what you're testing, right? Don't just automate your manual test. If you've got a whole bunch of tests that you've already got, or a whole bunch of scripts that you've already got that is testing your data warehouse, chances are it's probably a great big long script, several pages long, that does something. Okay, split it up. Make it easy, make it readable. One of the things that, Alan, if you can show your instances again, one of the things that's simple is each one of those SQL statements is testing one instance, right? If it goes wrong, you've got one place to look for. If the other instances are actually passing and then one is failing, you know the problem is there, right? If your vital checks are failing, you know the problem is there. Lots of simple scripts are much easier to maintain, especially if you have an automatic tool that helps you do it and it keeps the traceability between it, rather than having one giant large one with lots of complexity that takes a long time to understand and maintain. So with that, I'll say thank you. And if there's any questions, I'm more than happy to take them. Yes? For? Yes. I'm trying to work out what exactly I'm allowed to say about roadmaps, but so for RDBMS,
RDBMS you have solutions. So what's your roadmap like? When will you come up for NoSQL databases?
It depends what you want done with it, right? And it depends how you define NoSQL. So if we're talking Hadoop,
MongoDB, Aerospike.
MongoDB, the other one. Okay. MongoDB, we don't have anything on the roadmap yet. We have a lot of stuff with Hadoop. We have a lot of customers that are running Hadoop, either their own Hadoop instances or they're running Hadoop in the Azure cloud, for example. And we have a lot of functionality to be able to talk to Hadoop, be able to fetch files directly. Flat files are simple. NoSQL transaction stuff is simple. MongoDB, not on the roadmap yet, but if you want to come catch me after this, we can talk about what we need to do. I take it everyone's just been drinking from the fire hose and is completely amazed. I'll give you a few more minutes to settle. And
What was the brand? So from the business logic,
Mm-hmm.
what was the brand?
from the business logic in
yours?
that last
Is that
test,
like fire, health, or something? Or what was that representing in an abstract layer?
in that particular customer, they actually had one parent group that had lots of sub-businesses underneath it. And they would
okay.
trade under those different
Okay.
business names in different regions. So in one region, they'd be called X, another region, they'd be called
Okay.
Y.
Okay. So
Slightly different products in each
All
one.
right. That makes sense. Okay.
That is one bright light. I'm just going to stop here. No, well, in that case, I'm going to go get some food. Thank you very much.